right, if you would please, inside of your packet, I want you to skip the next 2 pages, and I want you to go into the very back page to shift shape and angles away for scale factor, perimeter, and area. All right, so we just finished up, this front side here where we're looking at similar shapes and we're looking at, looking at our corresponding sides and angles. So look for patterns that will help you describe the changes you see in perimeter and area when figures are changed proportionally. Okay, so letter A, it says number 1, draw a rectangle with a perimeter of 12 units. Okay, well, remember that perimeter is going to be my sides all added together. So I chose to draw a rectangle that is 2 units by 4 units. So my base is 4, my height is 2, my perimeter is 12, and my area is 8. Okay, because 2 times 4 is 8. 4 plus 4 is 8, plus 4 more is 12 to get me my perimeter. Okay, now I'm asked to enlarge your rectangle by a scale factor of 3. That means I'm going to multiply each of these dimensions here by 3. Well, 4 times 3 is 12. 2 times 3 is 6. So I need to get a rectangle that's a height of 6. So 1, 2, 3, 4, 5, 6. And then I need to go to a base of 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6. To give me my new rectangle here of 12 by 6. So my base is 12. My height is 6. Okay. Now I'm asked to find the perimeter of my new figure. So I'm going to do 12 plus 12 plus 6 plus 6. And I'm going to get 36. And my area is now 12 times 6, which is 72. Okay. 72. All right, so compare your results of the rectangles drawn by other students. When generalizing, can you make about the effects of the scale factor on the measurement of the figure? All right, so number 1, how did the scale factor affect the dimensions? So when I went from letter A for number 1 to number 2, how did my scale factor affect my dimensions? Okay, well, each dimension of my original is times 3 to get new dimension. Okay, I multiply each dimension by 3 to get to my new dimension. Okay, well, how did the scale factor affect my perimeter? Okay, well, think about it. My original perimeter is 12. I now have a scale factor of 3, so I multiplied 3 by 4 to get to 12. 3 times 2 to get to 6. Well, what can we say about my scale factor and my perimeter? What do we notice about those two? Well, look, 12 times 3 gets me 36. Okay, so my original perimeter, I just misspelled that, meter, is times 3 to get my new perimeter. My original perimeter is times 3 to get to my new perimeter. Okay. Well, how did the scale factor affect my new perimeter? Okay. Well, let's take a look at this. Well, let's think. Is 8 times 3, is that 72? Well, no. Let's think about this. 8 times what can get me to 72? Well, 8 times 9 can get me to 72, right? But let's also take this another step further. I want this number here that I'm multiplying 8 by. I know that it needs to equal 9, but I want this number right here. It needs to have something to do with my scale factor. So it has to do something with 3. How can I deal with 8 times 3 with something to get me to 9 to where I can have 72? Okay. How can 9 also be written with 3's and still stay with my scale factor? Well, it's going to be 3 squared, because what is 3 times 3? Well, 9. So 3 squared is equal to 9. Well, 8 times 3 squared is equal to 72. All right. So how the scale factor affects my area is that the original area is multiplied by your scale factored squared to get new area. It is multiplied by your scale factored squared to get to your new area. So no matter what your scale factor is, okay? So for example, 3 times 4 is 12, 2 times 3 is 6, 12 times 3 is 36. With the area, because think about it, we're adding all of this up. We've got these two different things. What do we have to do to find the area? Well, we have to multiply my two sides to find the area, okay? Same thing here. We have to multiply my two sides to find the area. So we need to take this area and square it, then multiply it by the original area to get to my new area. Okay? All right, let's try some examples here. So letter C. Several copies of a triangle were used to create the larger similar version of the triangle. How do the heights of the two triangles compare? Okay? So let's assume that this triangle is a 1 by 1 by 1. Okay, it makes our lives a little bit easier. So how tall is my bigger triangle? Well, 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Well, take a look. My larger triangle is 4 times the smaller. It's 4 times larger than the smaller. Okay. Well, how do the perimeters of the two triangles compare? Well, my original perimeter is 3 units, okay? And then what's my new perimeter? Okay, well, it's 4 plus 4 is 8 plus 4 more is 12. Well, 12 units. So how does the perimeter compare to the two things? Well, times 4. My perimeter is 4 times the original size. How does the area of the two triangles compare? Well, let's take a look. My original, okay, so think about it. To find the area of a triangle, it's 1/2 base times the height. So 1 times 1 times 0.5. Well, my original area is 0.5, not it's 0.05, 0.5. My new area, well, it's a 4 by 4, so 4 times 4 divided by 2, okay, is 8. Okay, well, let's think about this. If I'm told on the front that I'm going to take the scale factored and square it, I should be able to take my original perimeter of 0.5, multiply it by 4 squared, and I should get 8. So let's see this. 0.5 times 4 squared, and I get 8. All right. So using the given dimensions of the original triangle, determine the measurements of the image. So the height, the perimeter, and the area. The height, the perimeter, and the area. All right. So the original triangle is 3 inches tall. Okay. So I'm going to assume that my scale factor is still 4. Okay. That's what my scale factor is. So the height, I do the height times 4. So 3 times 4 is 12 inches. Okay, my perimeter, we multiply it by 4. Well, 12 times 4 is 48 inches. And my area is 6, so I'm going to do 6 times 4 squared. Okay, so 6 times 4 squared. And I'm going to get 96 inches. Okay, 96 inches. All right. Letter D, let's summarize your findings and use the relationships to solve the problems below. So how would you describe the effects on perimeter when figures are changed proportionally? And this is the easiest way. I would say I'm going to take my perimeter, multiply my scale factor to equal my new perimeter, which is what we did. We took our perimeter, we multiplied it by our scale factor to get to our new perimeter. All right, so Mrs. Capps has plans for a rectangular garden that measures 8 feet by 10 feet. Unfortunately, she does not have enough room in her backyard and needs to decrease the size of her garden. She only has room for a garden with the dimensions that are 0.75 times the size of the original dimensions. So there's my scale factor. It is 0.75. Okay, what is the perimeter of her new garden? Well, if we take a drawing, okay, we have an 8 by 10 of her drawing of her garden. Her perimeter originally is 8 plus 8 plus 10 plus 10. To have a perimeter of 8 plus 8 plus 10 plus 10 is 36, is it inches? No, feet. 36 feet. Okay? We are told to take our perimeter, multiply it by our scale factor to get our new perimeter. So 36 times 0.75, and my new perimeter of my garden should be 27 feet. Okay? So how would you describe the effects on the area when the figures are changed proportionally? So on the area. So we are told to take our original area, multiply it by my scale factored squared to get to my new area. Okay? So the rug in Danielle's room is 32 square feet. Over break, she made similar rug for her treehouse that is 8 square feet. What scale factor did she use to reduce the size of her rug? All right, so let's go ahead and use this. So I know that the OA, my original area, times my scale factored squared is equal to my new area. Okay? My original area is 32 square feet. And I multiplied it by some unknown scale factor to equal my new area of 8. Okay? I need to get scale factored by itself, so I'm going to divide by 32 on both sides. And I'm going to be left with scale factored squared is going to equal, well, 8 divided by 32 is 0.25. Now, how do I get just one scale factor? Is I'm going to take the square root of both sides. So I'm going to take the square root of 0.25. And I'm going to see that my scale factor is equal to 0.5. My scale factor is equal to 0.5. All right. Get a new copy here because I'm messed up on the other page. All right. Now we're going to go back to this page right here. So now we're going to go back to this page right here. So I have a figure A, and I'm going to do a couple of extra drawings on it. So the scale factor for each rectangle A to the new rectangle is 2.5. Label the dimensions of the new figure. Well, the height is 4 and the width is 8. Okay, I need to take a scale factor of 2.5. So I have learned that I'm going to take each side length and multiply it by 2.5. Well, 4 times 2.5 is 10. 8 times 2.5 is 20. So I'm going to make a rectangle that is 10 by 20, and I'm going to label it number 1. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I'm going to go to 20. 1, 2, 3, 4, 5, 6, 11, 12, 13, 14, 15, 16, 17, 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have a 10 in here, in here. Label it number 1. So I now have a 10 by 20. Okay. Then I'm told I need to draw a new rectangle with the area of 1/4 of my original area. Well, let's look. My original area is 4 times 8. Okay. So the original area of my rectangle is 32 units squared. I remember from my previous page is area times the scale factored squared to equal my new area. So I'm going to have 36 times, 1/4 squared is equal to my new area. So I'm going to do 36 times, well, whoops, not math, alpha y equals this 1/4. And actually, I'm going to go right here, and I'm going to square it. And I should get 9/4. Actually, did I do that right? No, hang on. 4 times 8 is not 36, it's 32. I did the wrong number, not 36, it's 32. So 32 times 0.25 squared, and you guys should get 2. I wrote down the wrong number. So I need to create a rectangle that has an area of 2. So let's go right here. And I got 1 and 2, and that's number 2. Okay. And then my next one, number 3, okay, number 3 says the perimeter of the new rectangle is 3 times the perimeter of the old rectangle. All right, so let me grab another color here. Let's do purple. I think that'll show up. So the perimeter, I'm told that the perimeter, I'm going to take the perimeter of my original. So I'm going to have 4 plus 4 plus 8 plus 8. That pen is dead. There we go. 4 plus 4 plus 8 plus 8. So I need to find my original perimeter. So 4 plus 4 plus 8 plus 8 is equal to 24. Okay, so I'm going to take my old perimeter, multiply it by my scale factor, which 3 times is my scale factor, to get to my new perimeter of 72. Okay, of 72. All right, now my perimeter, is going to be 72 units wide. That means I need to create a rectangle that is 72 units. Now, there are many different ways that you guys can try and do this, but I chose to do a 12 by 24 rectangle. Okay, I chose to do a 12 by 24 rectangle. So I'm going to do 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then by 24. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 20, 22, 23, 24. All the way right here. Right here. And I think, there we go. 12 by 24. And that's rectangle number 3. Okay, 12 by 24 to get me a rectangle number 3. All right. And here's what I want you guys to do next. You guys can skip this page of your extra triangles, but I want you guys to flip over to scale factor and similar practice. And I would love for you guys to complete problems 1 through 6 on your own. And if you guys have any questions, please let us know.